All right, here's video number 2, starting on number 9. Based on a survey of a random sample, 900 adults in the United States, journalists reported that 60% of adults in the United States are in favor of increasing the minimum hourly wage. There's a p hat. If the reported percent has a margin of error, so margin of error is z star times p hat q hat over n, is 2.7 percentage points, which the following is the closest level of confidence. So if we know the margin of error, 2.7 points, 0.027, trying to find the confidence, which is related to the critical value z star. So p hat 60, q hat 40 over, oh, that's not n. We'll do 900 there. You could basically do a little bit of calculator magic and get z star to be 1.645. That's a pretty common one, so it should kind of jump out at you that it's a common one. Remember, 2 or 1.96 is 95, so this should be a little bit less than 95. If you just look at the table on another page, just look for the confidence level at the bottom that corresponds to the 1.645, or thinking 1.645 or 1.65 and 1.65. Think about what the confidence would be in there. So if this was a 5% tail and that was a 5% tail, what would be the confidence? I'm not going to read this long one on number 10. I'm going to let you do that, but I'm going to remind you a little something about experiments. So actually, I'm going to pause. You should pause the screen and actually read over the problem again, because it talks about 70 stores to sell the CD, 35 were randomly assigned to sell the CDs with one cover design and 35 to the other. So randomization was used. So in an experiment, randomization really has to be used. So clearly one's out. The best answer is the one. Now also realize it does say best answer. And the best answer talks about randomization to the assigned stores, which in this case is D. All of those also just have small either errors or don't go far enough in depth. So like C, it says that the 70 stores were not randomly chosen. It talks about the random assignment to each store. And even though the 70 stores might not be randomly chosen, randomization is used. And it does say that there is a significant difference, which means actually it probably is reasonable to conclude, which that also eliminates C. So anyways, D would be the best answer. The manager of a public swimming pool wants to compare the effectiveness of two laundry detergents, detergent A and detergent B, in cleaning towels that are used daily. As each dirty towel is turned in, it is placed into only one washing machine on the premise. 20 towels, manager flips a coin, so it also uses randomization for detergent A or detergent B for that load. Then it's rated for cleanliness. So we're talking about completely randomized design, a block design with detergent A and detergent B as blocks, randomized block design with washing machine as the block, or a matched pairs design. Really quick, matched pairs design, or actually observational study. Observational study, absolutely not. Matched pairs design is when you have, when they're not independent of each other, where the first value would affect the second value. So a matched pair design might be if you're actually using both detergents. So if it's washed once with detergent A and then washed with detergent B, that wouldn't be independent because obviously it's going to be cleaner after being washed with detergent A first. So that wouldn't be it. Randomized block would actually be when you start with towels. So this would be by block design. Block design is when you start with the towels, and instead of going random right away, you break them up into groups or maybe different categorical variables. In this case, if you had like washing machine 1 as a block and washing machine 2 as a block, you'd separate them because you don't really know if they're both equally effective. And then you randomized with detergent A, detergent B, detergent A, detergent B, and this is where the randomization comes in. But anyways, it's important to realize we only have one washing machine, so we're not going to be blocking by washing machine at all. This most basic answer is completely randomized design because they randomize right away. 12. In the design of a survey, which of the following explains how to minimize response bias? When you think about response bias, that's wording bias. Read over that. That one should be fairly self-evident. 13. For a sample of 42 rabbits, the mean weight is 5 pounds, and the standard deviation weight is 3 pounds. Which of the following is most likely true? Well, I'd say start by actually drawing it out. You don't know that this is going to be a normal model, but start looking as if maybe. Let's see what happens. You start with a mean weight 5 pounds. So some of them are going to be a little bit heavier. Some of them are going to be really heavy. Some of them are going to be very, very heavy. But what's interesting is when we go downward and then we get into these negative values. Remember, these are weights of rabbits. So really, what's the minimum possible weight? It should be right about 0, which means we really shouldn't be thinking that this is going to be normal. I'll let you decide what you think it is. And remember, the skew is in the tail. 14 was actually omitted from the actual exam. Remember, this isn't a retired exam. This was because actually, as I'm reading this, I think they're all wrong. Whatever they marked correct for it, I'm not sure. But on your assignment, I have it so that they'll all be, whatever one you guess, it will be marked correct. 15, I don't want to take a whole lot of time on because I think you'll be able to read through and make a good judgment. Let's see how you do on that one. 16. Complex electronic device contains 3 components, A, B, and C. The probabilities for failure for each component in any 1 year are failure 1%, failure 3%, failure 4%. If one component fails, the device will fail. Since they say they're independent, the probability of A and B happening would be just probability of A times probability of B. Now it's talking about not failing. So if component A, the probability of component A failing is 1%. So the probability of A not failing, its complement, is 99%. Or the probability that all 3 of them not failing would be 99, 97, and 96. Multiply them out. That should be fairly easy. 17, large sample of 98. Oh, this is just asking the point estimate for a proportion in a confidence interval. That's just asking you for what p hat is. If p hat is, I'm just going to say p hat is plus or minus the margin of error. We have a high bound of 11.2 and a low bound of 4.48. P hat should just be right in the middle. Next video.